All right, so what we're working on today is equivalent fractions. You've done some fraction work before, probably in middle school, but this is just a good review. So the three things you have to be able to do is we have to be able to reduce, we have to be able to go from mixed number to improper, and we have to see whether or not things are equivalent. Before we do any of that, we need to figure out if it is what a fraction is. And so a fraction is just a part of a number. The most common fractions you've probably seen are those that have pizza. So if you have a circle, let's say my pizza is 8 pieces and you eat 3. So you just ate 3/8 of the pizza. Okay, and so that's what fractions are. Some vocabulary you have to remember. The top of the fraction is called the numerator, and the bottom is called the denominator. Okay, all right, and so there's several things we have to be able to do. The first thing we need to be able to do is create equivalent fractions. And so to find equivalent fractions, what you do is you multiply both the numerator and the denominator by the same number. Now, what's nice about this is that you get to pick the number. So you can pick any number that you're comfortable multiplying by. Most people are pretty comfortable multiplying by 2. So if I multiply the top and bottom by 2, 2 times 2 is 4, and 3 times 2 is 6. To find another one, I'm going to rewrite it again, so 2/3. This time maybe I'm going to multiply the top and bottom by 5. 2 times 5 is 10. 3 times 5 is 15. Another common one that people will multiply by is 10, because 10 is pretty easy to multiply by. So 2 times 10 is 20, and 3 times 10 is 30. And so that's how you find equivalent fractions, is by multiplying the numerator and the denominator by the same number. So now let's look at the next one on the right, 4/7. Again, I'm going to start with an easy one maybe, and maybe multiply by 2. So 4 times 2 is 8, over 7 times 2 is 14. And again, to find another one, just to stay organized, sometimes it's easier to write it down below. And so now I'm going to multiply by 10, because 10 I like. 4 times 10 is 40, and 7 times 10 is 70. And then if I want to do one more, let's see if I can move my mouse up. If I do 4/7, maybe times 3 times 3. So 4 times 3 is 12, and 7 times 3 is 21. And so those are my 3 different fractions that are all the same as 4/7. And these are my 3 different fractions that are all the same as 2/3. Now what I'd like you to do is go onto the left side of your notes, onto a separate page, and try these couple examples right here, number 1 and 2. See if you can figure out how to do 1 and 2. And when you think you have it, go ahead and push pause so that you can check your answers. So you should have set it up where you have 3 different fractions or 2 more. So maybe you did by 2, so that's 2/10. Maybe you did by 5, which is 5/25. Maybe you did by 10, which is 10/50. All of those are the same. If you would have done 3, you would have gotten 3/15. If you would have done 4, you would have gotten 4/20. For number 2, it's the same thing. I'm going to go ahead and write my fraction again. I'm going to multiply the top by the same number as the bottom. So I chose 2. 3 times 2 is 6, and 4 times 2 is 8. Maybe on the next one you chose 10. 3 times 10 is 30, and 4 times 10 is 40. Last one, let's say we chose 6. Maybe you like to multiply by 6's. So 3 times 6 is 18, and 4 times 6 is 24. So again, there's a lot of different equivalent fractions you can have that mean the same thing. As long as you multiply the top and bottom by the same number, you should be good. All right, the next type of problem we're going to have to do is we're going to have to reduce fractions. So for reducing fractions, this time I'm getting smaller. So instead of multiplying, I'm going to divide. That gets it smaller, okay? So I'm going to divide the numerator and the denominator by the same number. Now, it's helpful if you know your times tables, but if you don't, you should still be able to do this. So my best one to divide by is 2's. And remember, 2's are even numbers. So anything that ends in a 0, a 2, a 4, a 6, or an 8, 2 will go into. So if I look over here, 10 is even, but 15's not, so 2 doesn't go into 15. But you should recognize your 5's. And 5 goes into both of these, so 10 divided by 5 is 2, and 15 divided by 5 is 3. So you are done with that, because that's the smallest number. The difference between these two types of problems is up here, you are trying to find bigger numbers. Down here, you're trying to find the smallest one possible. All right, let's look over here, 32 over 40. Well, 32 is even, and 42 is also even, so I'm going to go ahead and divide by 2. So 2 goes into 32 16 times, and 2 goes into 40 20 times. Well, look, these are even again, so I can divide again. So this time I get 8. Don't forget to do it on the bottom, over 10. Almost done, but those are still even, so I can divide again. So now I get 4 over 5ths, 4 over 5, and that's the answer. Now, some of you might have looked at this problem, and if you know your times tables, you might have recognized it. Oh, 8 goes into both of those. 8 goes into 32 4 times, and 8 goes into 40 5 times. So it doesn't matter which way you do it. Some just takes longer, but you still get to the same answer. All right, what I'd like you to do now is go to the bottom again, or to your other side of the notes, and I'd like you to try this number. We're supposed to say number 3. Number 3 and number 4. All right. Okay, so you should have tried these. You should have hopefully recognized that 3 is even, so 2 goes into both of those. 10 divided by 2 is 5. 24 divided by 2 is 12. And then that's reduced. There's nothing else you can do. Same thing for number 4. It is also even numbers, so I divide both by 2, and I get 14 over 25. And that's reduced. There's nothing else that can go in those. So reducing may seem harder because you have to divide, but in the end, it might be less work because you only have to find one answer. All right, last type of problem we have for these notes. Oops. Last type of problem we have is writing mixed and improper fractions. So we need to know what the difference of these are. We got an improper and we have a mixed. Okay, so a improper fraction is when the numerator is larger than the denominator. Some examples might be 10 over 3, 22 over 4. So those are improper fractions. A mixed number is when there is a whole number and then a fraction part. So something like 5 and 2/7, or maybe 1 and 3/4. Those are mixed numbers. All right, so that's, first of all, you have to know how to do the difference of them. Now let's actually see how to do them. Okay, so what happens here is you have to say, how many times does 3 go into 10? Well, 3 goes into 10 evenly 3 times. 3 times 3 is 9. So that means from when I divide, I have a remainder of 1. So my remainder goes on top, and then my bottom number stays the same. So since I divided by 3, I have to divide by 3 here. So it's 3 1/3. So here, 4 goes into 22 5 times, because 4 times 5 is 20, but that means my remainder is 2. So remainder goes on the top, and then again, your denominator stays the same. So since I had a 4, I have to have a 4 here. And now what I hope you see is that 2 fourths can be reduced. I could divide both by 2, and so really 2 divided by 2 is 1, and 4 divided by 2 is 2. So that's the actual answer. So that's how you go from an improper to a mixed number. So why don't you try this one right here. Okay, you should have noticed that 5 goes into 33 6 times, and 5 times 6 is 30. So that means I have a remainder of 3. And then remember, the denominator stays the same. So it's 6 3/5. All right, let's change colors to do the next one. Okay, and so now I got to go backwards. To go backwards, I'm going to multiply first, and 5 times 7 is 35. And then I'm going to add. So it'll be 35 plus 2. And 35 plus 2 is 37. So it's 37 over 7. Same idea. Denominator stays the same. The same thing here. I'm going to multiply. 1 times 4 is 4. But then I'm going to add that 4 plus the numerator. And so I get 7 over 4. Okay. And then you guys try this one over here, the 4 1/5. See if you can get this. You should know that the 5 has to stay on the bottom because the denominator stays the same. So did you do 4 times 5 to get 20? And then do 20 plus 1. So times, then plus. So it's 21 over 5. So fractions, the big deal is just practicing. And so there's a lot of different terms and a lot of different processes, but the more you do, the better you'll get at it.